So as I'm just reminding you guys, we're looking at 2015 Unit 1, Chemistry Unit 1, Paper 1, right? So which of the following statements is not a part of Dalton's atomic theory?
B.
Okay. The intermolecular forces which are present in ice are?
Hydrogen.
Wonderful. Which of the following pairs of elements combine to produce naturally occurring compounds with the formula? Hold on. Give me a second. Wait. This is a Cape paper? These are CSEC questions. I saw these questions, I'm like, wait. What's CSEC do right here? So, okay. So that's the answer there. So, because I saw number 5 and number 6, I was like, this is upon CSEC paper. Alright, so let's look at this. Which are the following pairs of elements combined? This is literally a CSEC question. This is a question, the answer was XY and they're asking for the element. But okay. So, what is the answer for this? What would you combine as XY? Would it be magnesium sulfate?
Yes, sir.
Alright, magnesium sulfate. What would be the pi bond here?
C.
Wonderful. Right. What would happen up here? So now we're looking at 238. Uranium 238 is bombarded with a neutron. How many fundamental particles, protons, neutrons, and electrons does an atom of the product contain? What would be the product after a neutron is bombarded with it? What would happen? So if a neutron is bombarded with the uranium 238 U2992, right? Plus the neutron, which have what? A mass of what? Proton number 0, mass of 1, right? What is going to happen? Is the proton number going to change?
Yes, sir. It's going to increase.
Sure.
No, it wouldn't.
I want to know, will it increase or will it not? If it won't increase, B is the answer, of course. But if it does increase, then we have to decide between C and D. So we're saying that when we bombard something with a neutron, does the proton number increase? I'm looking in the chat now. What does everybody say? Javon, Jada, Delicia. What is the answer? What happens after the bombardment of a neutron? Rion? Shania? Or Shania? Sheen? What happens? Mass number increase, right? But the number of protons don't increase. It's a neutron. So if we look at that, it's going to increase the neutron number, is so? But if we're looking at it like that, and if the mass number does not, if the atomic number does not change, then it will remain as 92. The answer here, how do we get the answer for this?
You go times the atomic mass by the abundance and do everything. Yeah, that.
Yeah, you're correct, right? Atomic mass. Abundance. I tend to mix up all my letters, by the way, right? I'm terrible at spelling, just saying. Alright, and it's gonna be divided by 100 overall. Alright, so we're gonna find the sum of all of those. What would be the answer? This is a repeat question too. So what is the answer?
D.
Alright. So let's look at this now. if 10 centimeter cubes of nitrogen reacts with 30 centimeter cubes of hydrogen at STP, the volume of ammonia will be? What's the answer? Waiting for an answer.
Sir D.
That does sound like a answer that has any confidence behind it.
Sir, I must see you now, sir.
It's because of the number of moles you're looking at.
Yes, sir.
Okay. Alright. I think this should be a long equation, you know. A long equation. Because what you're going to have to do for this, right, you're going to have to start out the mole ratio, right? Then you're going to have to find the number of moles of the hydrogen, number of moles of nitrogen as well, right? Then you're going to use a stoichiometric equation. You're going to balance the stoichiometric equation. Then what you're going to know is going to times everything by 2. Well, times the number of ammonia by 2. And you're going to get that will be what, 2 times number of moles of ammonia, right, will be around 0.8 something, if I remember. And then the volume, you're going to have to times it, and what you're going to get is 19.99 centimeter cube, which is C. So it's a bunch of stuff to go through. Like the equation is just long, but you're gonna get 20. Right? Well,
Sir, I see that.
repeat.
I'm surprised it was C.
Yeah, I mean it should be C. It should be C, right? Because one STP, right? When you speak about the volume at STP, right? It's standard temperature and pressure. That means that 1 mole must occupy, right, that amount of space at STP. Therefore, if you have 2 moles here, to give you that based off of this question. No other question, you know. You have worked out with the other question then. Right? Because the Haber process is simple like that. It's similar. It's something that people tend to know. Right? So 20 would be the answer here. But yeah, exact answer is 19.99. 8. The first 5 ionization energies of the element X are given here. From the data, it can be deduced that X is a group 1, group 4, group 5, group... I saw that some person put group 2 for this, but group 2 is not here, so what would be the answer? Group 1?
Group 1.
Alright. Looking at this, the complete reaction, 0.25 grams of a monobasic acid requires 10 centimeter cubes of 0.2 mole per dm cube sodium hydroxide. What is the relative molecular mass of the acid? .25 grams of a monobasic acid requires 10 centimeter cubes of 0.2 moles of sodium hydroxide. What is the relative molecular mass of the acid? Waiting for you guys to come up with the answer. You guys got the answer yet? Okay, do you guys know how to work this? Yes, no.
Maybe.
Alright. A you get. Alright. Okay. We're going to do some conversion here. Would we like to convert in the middle or the end? I mean, we have to convert in the middle anyways because I would like to find my number of moles. Okay, so let's look at this, right? So the mass of acid is 0.25, right? The volume of sodium hydroxide is 10 centimeter cube. Alright, which is 0.01 dm cube. So the concentration is 0.2 mole per dm cube. Right? All of that is already in the question, by the way. Right, so let's look at this. We're going to have to balance this equation. We say a monoprotic. Right, monoprotic. I don't know why it's basic, but sure. We say HX plus sodium hydroxide should give us, right, what? NaX plus H2O. Now so that's true. So we'll have a 1-to-1 ratio between that and the sodium hydroxide. So if we have a 1-to-1 ratio, right, all they have to do now is find the number of moles of sodium hydroxide, which is the concentration times the volume, right? And the volume here is 10 centimeter cube. So if we find the number of, you guys are following? Are you guys following? Following?
Yep.
Alright. So the number of moles of sodium hydroxide is going to be the concentration times the volume. The volume would have to be in dm cube. Therefore, the number of moles will be what? 0.002, right? Because it's 0.1, so it's 0.02 is the answer. 0.002, I mean. Right? So 0.002 mole. We have that so far. Now, according to the mole ratio, there's 0.002 moles of acid as well. Not true? Not true.
Repeat, sir.
If we have the moles of sodium hydroxide to be 0.002, that means that the moles of the acid is 0.002 as well, right?
Yes, sir.
Alright, so the molar mass is what? Now the mass of the acid is 0.25 divided by 0.002. Not so? Mass divided by moles give you molar mass. The answer is 125. The answer is 125.
Oh, yes, sir.
So
120.
for the person who got 12.5, how? I got 125. How you get 12.5? Can maybe just be like a conversion issue. I don't know. But how you get that? Ah boy, so give me one moment. Just something wrong with the pen real quick. Here. I'm not sure how the person got A, but I would get 125. Okay, Shayna, you said A. I'm not sure what's happening. Why you guys say A? Oh, what was 20? Oh, alright. I was seeing it. Okay. So we can move on now. Shouldn't take too long. We can move on. Alright, so the answer here is C, in case it comes back, because I don't know, the papers like to bring stuff. Oxidation would be the addition of oxygen, so we don't really have to sit down and waste the time in the exam looking for oxidation number. Which of the following groups of solids contain substances that all have giant structures? So giant carbon dioxide on a giant structure. Stop capping. Iodine on a giant structure. Stop capping. And that make it worse right here. So graphite, iron, and sodium fluoride, right? Now let's look at this. What is the activation energy of the reverse reaction? Q plus P? Because if this is the forward, then in the reverse it has to accomplish Q and it has to accomplish P. So that means that the reverse reaction for this would be not feasible. Or well, it's not that it's not feasible, you know. It's the energy is gonna be pretty high, so it's not gonna be spontaneous. Right, the Gibbs free energy of the reaction. You guys gonna look at that after. Right, this would be PV equal nRT, you know, so or P1 V1 P2 V2. This is P1 V1 P2 V2, right? This is a repeated question, that's why I'm just jumping into it. And the answer would be B, but where do you guys get this? The gas in the syringe occupies that, right? So we have V1 at the pressure that, so we have P1 equals X V2. So we're looking for X. Is that right? Alright, no here anybody. So I'm just going to move on. So we're going to have what? P1. Wait, hold on. This is moving a bit slow. P1 V1 divided by V2. You should get B. Everybody's fine with that?
Yes, sir.
Alright. Moving on. The simplest formula for a compound that contains 50 sulfur and 50 oxygen by mass is B, right? 1 sulfur is 32 and 1 oxygen is 16. 2 16 is 32, therefore it should be 1 sulfur and 2 oxygen. Let's move on. A student was asked to carry out an experiment to investigate the properties of ionic and covalent compounds. Which of the following experiments should the students use? Alright, we could look at probably determining the melting point and the electrical conductivity. Enthalpy of combustion would be helpful. Would that be helpful?
No, sir.
Sure.
Yes, sir.
Alright. Everybody agrees that 2 and 3 will be the answer? Is there anybody that disagrees? Go ahead.
Oh, sir, I don't disagree. I'm saying.
Alright. 2 and 3. With what is the effect on a chemical reaction of introducing a catalyst in it? So does it, well, it should increase the rate to some extent. So A, the activation energy is lowered, and we can know that through the Boltzmann distribution curve, right? The rate law for this reaction is that what is the units of K? What gonna be the units of K? We can have mole per dm cube. Wait, hold on. Mole per dm cube, right? Per second. Is it gonna be per second as well? Rate is mole per dm cube, right? Per second. So I have mole per dm cube per second. Wait, we're looking at for what? Units of K specifically. Oh, so K will be equal to the rate divided by, okay, mole per dm cube. right? So first of all, right, if we're going to square the first part, it's going to be mole squared dm to the negative 6, right? And we're going to times that by mole dm cube, right? What we're going to get from that is what? No mole, go ahead.
I'm saying the answer is D.
Yeah, the answer will be D. Well, should be D, right? But I'm just going through it. So when we divide these, we're supposed to get, alright, so that will be negative, that will be positive, so the 6 will be positive, D is the answer. Alright, so moving on. Number 18, in a standard hydrogen half cell, a platinum electrode is used to. B, right?
Yes, sir.
Alright. Ammonia is removed from a system represented by these equations. Which of the following statements about the system is false? Case remains constant. There is a change in all concentrations. The equilibrium position remains the same, or the rate of both the forward and reaction and reverse reaction is decreased. What is false?
Sure, C.
Okay.
Wait. Yeah, C.
Sure.
Yes, sir. Sure.
So if I remove that, the equilibrium position is not going to remain the same. So if I remove these, so if the concentration of ammonia goes down, the equilibrium position isn't still going to be to the right. In favor of the products. Explain to me why it's a C. I'm not telling you that C is wrong, you know. I'm asking a question about it.
Sir, because if ammonia is removed, the system will have to make have to do something about that change that was made, sir. So it cannot be that the equilibrium position remains the same.
Okay. Alright. Everybody else agrees? Do we agree with that?
Yeah.
Sure. So we're saying that equilibrium position probably would push more over to the right in order to increase the rate of the forward reaction, right? To, well, re-establish the amount of ammonia. Go ahead.
No, sir, I was just saying the same thing.
Okay. So Javon, you agree? Selena agree? Monique agrees? Do you guys agree with that? I'm not hearing anything out of you guys now. Kimberly, do you agree? Alright, we're not hearing anything out of them. They work in the chat. Okay. Let's look at this now. I have never seen this question. I don't know why. Alright, if the half-life... Oh, we're looking at half-life. That's cool. So you guys looked at half-life before, right?
Ages ago.
Okay. So it should be fine. So go ahead. What is the answer here? Waiting on you guys to solve this now. All you guys are sparks, right? So you guys should be fine. So we're saying if the half-life is 253 seconds, then what is the value of the velocity constant K? I want you guys to quickly answer this, right? If you can, please quickly answer it. I don't want you to spend time, right, enjoying chemistry, right? We want to really complete this first, and then you can, spend time and enjoy yourself as it relates to chemistry. I'm not sure how to get the answer to this. Oh, lime, don't forget it immediately. Alright, what you guys have as the answer? I give you guys enough time. What's the answer? Hello? Knock, who's there? What do you guys have for the answer here? Have you guys started?
I know it not what was. I know it not what to do.
Okay, you want me to give you an equation then? And you use that? Let me give you a formula, I guess, or an equation. So the T half is equal to ln 2k, and we know that ln is equal to the log to the base e, right? So you guys can have fun with that. So what is k? So ln that formula, man, and then we move on. Well, make k the subject of the formula, and then plug
The
in the
answer will
values.
be D.
D, wonderful. Everybody see we get D? Or you want me to work through it? I have a natural log it, ln is the same thing of log 2e. You guys have never encountered this? Everything just silent, so.
First time I see it, to be honest.
Euler's number.
Remember it, but I don't remember it.
Ah boy. Alright, so we're just going to have to natural log it, right? So remember that the half-life, right? T half, right? So that half-life is gonna be equal to the natural log of 2 divided by the rate constant k, or the velocity constant as you refer to here, k. So that's all you have to remember, and then you just find k. Solve for k. You guys understand the concept of ln, right? You guys did logarithms, right? Everybody's fine with that? Okay, I'm gonna assume that we understand what's happening here. And just
Nope.
okay.
Nope.
Hold on. ln is on your calculator?
Sir.
Go ahead.
The 2, is it always there, sir?
Yeah, it's a part of the equation, I believe.
Okay.
You guys know ln is on your calculator? Is ln on your calculator? It should be.
Yes, sir.
Yeah, so it's ln the 2. And move on with your life. Alright, just ln the 2 and plug in the equation. Go ahead.
So a half-life divided by ln2 or multiplied by.
Wait, k is equal to. K will be equal to what? K no ln2 over the half-life. K no ln2 over the half-life. This is a half-life, which is this value right here. So it's going to equal ln2 or ln2.
Get it, sir.
Alright. ln2 is 0.6931471,806. Right, so it's going to be basically equal to ln2 over your 253. And you should get the answer. Alright, so you guys should be fine with that. Moving on to greener pastures. Alright, which of the following which of the acids in the table below is weakest? K is what to acidity? K is directly proportional to acidity, right? That means that the greater the Ka, the stronger the acid. Which one here is the greatest Ka? The D. Right?
Yes.
Wonderful. Moving on now, the value of the Kp for the equilibrium reaction here, right? What is the value of the Kp if the pressure is changed to 2 atmospheres and the temperature remains the same? 50, right? If it's Kp, if you change the pressure, you think that the Kp shall change? Or equilibrium will restore the power? Or restore it? Do you think that it will change to 100? Or 200, or it will decrease to 25? Go ahead. Does pressure, just changing pressure, affect Kp? That's what I'm asking.
No.
Okay. So changing pressure does not affect Kp. Well, I mean, it technically does, right? But it will have a minimal impact, to be very honest. It technically does, but generally no. Equilibrium is established for the reaction here if the equilibrium concentration is, please. Oh, never mind. I thought it was I stable. Because the way we would just end the meeting right here. So if the equilibrium concentration is X, that. Okay. What are the values of the equilibrium constant K? So we basically just have to plug in everything. So Kc is equal to what? Products over reactants, right? What's the answer here? What's the answer here? 0.6 divided by 0.2 times 0.3, and our answer is 10. What are the units of K? Will it be squared? Go ahead.
Yeah, D.
Let me just make it clear for the persons who may not be so adept. Just to be very honest now, right? No, never mind. Let me explain it after. Let me do that after. Yeah, D should be the answer. Right. Let's move up now. I don't particularly like this. Okay. So which of the following represents the reaction with order reaction with respect to propanone? So we have propanone here. How do we find the order reaction with respect to something? We find where it changes and everything else remain constant. Yes or no? Or where it is constant, everything else changes. What we do? What do we do?
So I'm just remember say you look for what is constant.
Okay, what do we look for which is constant? Is the propanone looking to be constant?
The
Okay.
iodine.
Iodine. Oh wait, so we're looking for with respect to propanone now. So you sure say it isn't? Okay, hold on. So you want iodine and you want the hydrogen ions to be constant, but the hydrogen ions can't be constant. Because there's no place in which it is constant and then it changes like that. So we're looking for the iodine alone to be constant?
Yes, sir.
So we disregard this. That you're saying?
Yes, sir.
Okay, if we disregard it, let's see what's going to happen. Let's take 2 and 3 then. What would be the answer? You're sure that we disregard that value there? Seems a bit off, you know. You're sure? Okay, I haven't done this in a while, you know, but I don't think you guys should disregard that per se, but I'm not seeing an area in which you can't. So okay, if we disregard that same way, 2 and 3, what would be the difference in what would be the order of the reaction here? Kind of move by like 0.1. So is the rate doubled or anything? Would we see anything there?
One side are 2, and the other side are 1 point some.
I have to look at the rate, you know. So anything specific happened to the rates? Not really. I don't like this question. Alright, I don't like this question. You see? Absolutely not. If we took 1 and 3, if we took 1 and 3 there, we would have doubling happening. Alright, it would be what first order? If we took 1 and 3. But that means that hydrogen ions have something to do with the rate of the reaction, because the hydrogen ion is the only difference in it, and that makes a huge difference here. But we can't find, can you guys find any place where propanone changes, iodine remains constant, and a hydrogen ion remains constant? I don't think so. Because we have to find an area in which this can recur, but the propanone changes to 0.5. Alright, what would be the answer here?
B.
B, you're saying the answer would be B? If we disregard it, the answer would be B. Well, I don't think you guys should disregard it, but I don't see any better way to do it though. So there's no way for the hydrogen ions to match up, so I would go with first order. Because of the jump from the 5.4 to 10.8. You guys are following? Are you guys following? Everyone else? Sure? Alright. Because I don't find it anywhere matching up. But if you guys find like a different interpretation to the question, please tell me. The solubility product KSP at standard temperature for 3 group 2 metal sulfates is given in the following table. Alright, so we're looking at which ones, right? Well, the metal let me just read the rest of it. Which metal sulfate would precipitate out of solution if equal volumes of 10 to the negative third power mole per dm cube solution containing the sulfate ion and the group 2 metals are mixed. Wait, is that cubed? Oh, that makes sense. Oh my. Alright, hold on. KSP. Let's look at this, right? KSP value would have been mole squared per dm cube, but the concentration of each ion would be different, right? So if we look at calcium, we're going to have calcium 2 plus, right? And sulfur, right? 2 negative, right? Can you divide the KSP by 2 and see what you get? 2.4 times 10 to the negative. You guys see what I'm doing? I'm not sure if you guys see what I'm doing, but I'm trying to get the value for each individual thing. Each individual what you'd call it now. What do you call it? Each individual ion per se. So each of these ions here is 1.2 times 10 to the negative 5 power. Right? If I do it for here now, strontium, right? Strontium is in what? Group 2 too, right? So all of them are gonna be the same. I'm just gonna divide all of the values by 2. Give me one moment. Let me just do that real quick. I'm trying to see if this will work, and then I explain it. Divide by 2, I should get generally that. All of them should get that though. So it's probably speaking about, okay, let's see, solution containing the sulfate ion from the groups of metal are mixed. Alright, so I would believe that 3 would be in it and 2 would be in it. We're probably just looking at the solubility of the sulfates. Alright? Well, wait, hold on. I'm not supposed to be divided by 2, you know. Give me a moment. Times 10 to the power of negative 5. If I should square root all of this, 2.4 times 10 to the negative 5th power, I should get 4 to the 3rd. Alright, 33.2 times 10 to the square root 3.2 times 10 to the power of negative 7. Right, that should give me to the 4th power, and 1.6 times 10 to the negative 10. That should give me, well, if I square root it, that should give me 5. What do you guys think would be the answer here? Hello? Guys, I'm not hearing you guys. If you're speaking, what would be the answer? Amanda, what would be the answer? Alicia, what would be the answer? Kimberly? Not hearing anything from you guys, you know. Not hearing anything from the young women here. What do you guys think is the answer? I don't want to spend the whole day on it, you know.
Sir, A.
Okay, so A is the answer for you. Anybody else has any other answer other than A? There are 15 people here now, and only one person have an opinion on the answer. Nobody else has any idea what to put. So A is not bad enough because barium sulfate will form a precipitate, alright? Strontium sulfate should form a precipitate as well, and calcium sulfate should form a precipitate. So I was wondering if D would be the answer, because all of them technically should form a precipitate generally. We're looking at will precipitate out. Which metal would sulfate will precipitate out of solution if we have that? We should have all of them, no? Alright, so I think that all of them should generally go out, but 1 and 2 or more. I think all of them will form precipitates because based off of module 3 content, right, all of them should form precipitates, right? But I understand why you go for A first, the person who answered A, because barium sulfate would be the most likely, but strontium sulfate as well can do it, and calcium sulfate as well can do it. So I was looking at that. Silver chromate is sparingly soluble in water. The units of solubility, KSP for silver chromate are what would be the KSP for silver chromate? What would that be? It would be 2 Ag plus 1 CrO4 2 negative. Therefore, the KSP value would be Ag plus squared plus CrO4 what 2 negative, right? So it should be C. Barium carbonate is more soluble in water than its aqueous sodium carbonate because what would be the answer?
Guessing D.
So barium carbonate is more soluble in water than. Alright. The common effect?
Yeah, the common ion effect.
Common ion effect. What does the common ion effect speak to? What's the common ion effect?
Something when time you add a salt to a solution, we have similar ions to it.
It's going to reduce the solubility. So I don't think this is the answer. If you add something which has already has the ion present, right, which is already present in solution, it reduces the solubility and precipitates out of solution. So D wouldn't be the answer as to why barium
Or the
carbonate is more
common
soluble.
ion effect would decrease solubility. So yeah.
So why is BaCO3 more soluble than NaCO3?
B, maybe B.
Wait, hold on. You see, my issue with this, is that I don't know if there's an issue with the question because barium carbonate should be less soluble than sodium carbonate, just saying. But I don't know what the issue for this would be. I get what you're saying, but like I'm trying to find the answer as well. It said B, barium ions cannot displace sodium ions. The displacement doesn't really have anything to do with the dissolution, though. Don't think so. Because they would just dissociate. But what my problem is that barium sulfate is supposed to be insoluble, right? And I'm not sure about sodium. Well, I mean, sodium carbonate should be more soluble than barium carbonate. Sodium carbonate should be more soluble. So I'm not sure what's wrong with that question. I think there's something wrong with this question because barium carbonate should be more insoluble than the sodium carbonate. So it's less soluble. I'm not sure why them say more soluble, and I don't know how to explain it if it's wrong. I think this statement up here is wrong. I'm not sure about that though. What do you guys think?
Some look wrong with the question. Like, I don't know if I less soluble or then just forgot to put sodium where barium is.
They are comparing the solubility of the carbonate in water and in the sodium carbonate. So I think D will really answer.
You think D would be the answer? Okay. That's what you're saying, but are you saying that even though they're asking that if you still put the common ion effect, it's still gonna be like the solubility? But technically, barium carbonate is supposed to be less soluble than sodium carbonate. So what it's saying is that I'm supposed to justify why barium carbonate is more soluble, which is wrong. So I don't know. But you would, I guess, I don't know. I don't know what the answer is. I don't want to answer it and put something that is probably indecent. Right, so I recommend that you guys probably look for it. Go ahead.
Sure, that's why I said D, because I never know what to put, because he said, in D's answer, it said that a common ion effect is present in the barium carbonate or the sodium carbonate mixture.
Okay. I guess that is the safest answer for real. Alright. Let's have a look here then. A weak acid dissociation, we saw this already. Marine animals, we saw this already. 1 and 2. Standard enthalpy change. What it should be is less negative than that. D is the answer. As greatest polarizing core, it should be the smallest one, which is beryllium. That is the answer. Many of these repeated, so just saying. Which of the following properties increase as we descend the group? That increases, that decreases, and that increases 1 and 3. Silicon carbide has a structure similar to that of diamond. What are the advantages derived from using silicon carbide ceramics when compared with steel?
Well, all of them are advantages, so.
Okay, all of them. Alright. I think that repeated as well, enough. Let's look at this. Which of the following factors best explains why barium carbonate is more stable than magnesium carbonate? Okay, that makes sense. This makes sense though. Right, so magnesium are very different in size. I mean, that doesn't really best explain it if you just tell me that they're very different in size. Oh wait, I just saw it. Okay, very different in size. So is magnesium more stable? That is not true. They're not very different. I think this should be it. And this 1 and 3. Alright, because they're able to distort the electron cloud a little bit more. Well, not distort. Is it distortion? They're able to expand the electron cloud and distribute charge more easily. Right, so the larger the ion, right, the less the polarizing power, and the less the polarizing power, the more stable the carbonate. Alright, based on the positioning group of 7, right? Is 7 this? Of the periodic table, acetine at room temperature and pressure is most likely a solid, right? Following?
Yes, sir.
Makes sense? Okay, which of the following properties does not describe transition elements? All the metals are referred to as magnetic in some way. Yes, C. Wonderful. Moving on, 37. Which of the following elements in the third period has the same oxidation number in all of its known compounds? We're going with B as answer here. Wonderful. We looked at this already. This is A. This is different. The ionic equation for the formation of chromium hydroxide and chromium sulfate in dilute ammonia is
D.
okay, so D is the answer. Everybody else agrees?
I say D too.
Okay. So that should give us but it's not balanced though. Wait, hold on. Is it balanced? Let me check something. That is gonna be bonding with that. Well, I mean, it technically balanced. It's good. It's not terrible. Alright, so I think D would be the better answer. Because first of all, this is chromium hydroxide and this is chromium hydroxide. That is not it. Right? And there won't be only one of these. So yeah, that makes sense. On heating calcium sulfate strongly, it decomposes into calcium oxide and sulfate, sulfur trioxide. Calcium carbonate decomposes at a much slower temperature than calcium sulfate. Which of the following factors best explains the greater thermal stability?
C.
So the calcium ion is more easily polarized than the sulfate ion. Sure?
Yes, sir.
I mean, that makes sense. If I think about the stereochemistry of it, it's going to be larger, right? So it's going to be, so the calcium ion is smaller than the sulfate ion, so it's going to be more easily polarized by the calcium. That seems fine. When the concentrated sulfuric acid is added to solid potassium iodide, the observations are white steamy fumes and
C.
Okay, we're gonna have the sulfuric compound being created. Which of the elements in the table can be classified as a transition element?
1.
1.
A.
Okay. Elements can be classified. We saw this to be cobalt. Lowest pH, we saw this to be. Wait, lowest pH, we saw it to be A though. Sorry about that. So it should be A. And then this now, chlorine is a stronger oxidizing agent than iodine. And that should be the end of this. That's the end of the 2015 paper.